The topic which we are going to discuss is application of stack. So after viewing this video, you can able to convert the infix expression to the postfix expression, and you can able to evaluate the postfix expression. So before going for the algorithm of infix to postfix expression, first we need to understand the notation of prefix, postfix and infix notation. Okay. So the infix notation, to add a comma b, we write a plus b. So to multiply a comma b, we write a star b. So the operators plus or star or minus, whatever it is, it go in between the operands a and b. This is known as infix notation. Prefix notation, instead of saying a plus b, we could say add ab. So how we are going to write is plus AB. So the operator comes the first, then the operand. Operand is nothing but AB. Operator is nothing but addition, subtraction, multiplication, those things. This is known as prefix notation. Postfix notation, another alternative is to put the operators after the operands, as in AB plus and AB star. This is postfix notation. So the important note is the terms infix, prefix and postfix tells us whether the operators go between, before or after the operands. Infix means between, prefix means before, postfix means after the operands. So this is the algorithm of infix to postfix conversion. So here I am giving the words as vector, infix vector, then stack vector, in order to store the information in a particular place. So for example, so before that, let us look at the algorithm. First, use a loop to read the tokens one by one from a vector, infix, from a vector in the sense from the infix vector of tokens representing an infix expression. So the infix vector contains the infix expression. We are going to read the tokens from the infix vector. So for each token, we need the looping is there. For each token, when the token is an operand, then add it to the end of the vector of postfix vector. So importantly, what you need to know is there are three things: stack vector, infix vector and postfix vector. In the infix vector, that is the input. So in that we will have the infix expression. Our goal is to convert the infix expression to the postfix expression. So in between, the stack vector will be the mediator to convert the infix vector to the postfix vector. So initially all the content expressions will be in the infix vector. With the help of looping concept, we are going to take each and every operand one after the another. So when the token is an operand, then we need to add to the postfix vector of the token that is used to store the corresponding postfix expression. But if the token is the left parenthesis, that is open parenthesis, then push back the token x to the end of the vector, that is stack vector of token that simulates a stack, which is nothing but a stack. Okay, so whenever if you found the left parenthesis, then put that left parenthesis onto this stack. When the token is right parenthesis, then immediately you need to pop back a token from the stack vector and push back the token to the postfix vector. So whatever the content between the open parenthesis and close parenthesis, those things are written into the postfix expression one after the another. If this stack vector is already empty before finding open parenthesis, that expression is not a valid expression. So it must be the balanced symbols. If there is an open parenthesis, then close parenthesis should be there. Then it is considered as the valid expression. Otherwise, that expression is not a valid expression. So if there is an open parenthesis, immediately there will be the close parenthesis also after some of the operands. So when the token is the operator, when the token is an operator, again we need to check the condition whether the stack vector is not empty or not. The token y currently in the end of the stack vector is an operator. In other words, it is not a leaf parenthesis. Then y is an operator of higher equal precedence than that of x. So if there is a open parenthesis, soon after if you get the closed parenthesis, you need to pop the content from the stack and put it onto the postfix vector. The most important thing is whenever you are inserting the operator into the stack, need to check the higher or equal precedence are there or not. If the operator is higher than the operator which is in the stack, then you can put the operator over there. But if you are going to put the lower precedence after the higher precedence, so during that period you need to pop out and insert into the post vector. This is how we are going to convert the infix expression to the postfix expression. As long as all the three conditions above are true, in the loop above repeatedly do the following in the body of the loop. Call pushback to store a copy of the token y into postfix vector, and call popback to remove the token y from the stack vector. Okay, this is the algorithm for infix to postfix expression. So after all the loop process has been done, and if the stack contains any of the operator, then pop all those things from the stack to the postfix vector. For example, see, here we are having a stack, infix vector and the postfix vector. So initially the infix expression a open parenthesis a plus b minus c close parenthesis star d minus open parenthesis a plus f close parenthesis. So initially we are going to insert the open parenthesis into the stack. Then whenever we found the operand a, we are inserting into the postfix vector. Then after reading plus whenever the operator is reading, we are going to insert into the stack. If we read operand, then we are going to insert into the postfix vector. Next one is operand, so we are going to insert into the postfix vector. Next we are going to look at here. Next we are going to read the operator minus, so we are going to insert into the stack. So while inserting, we need to check the precedence, whether it is higher precedence or lower precedence. If so, plus and minus are the equal precedence. So before inserting minus, we need to pop out the plus, and then we need to insert the minus into the stack. That is what happened over here. Next we are going to insert C. So we are inserting the C into the postfix vector because it is an operand. Next we are going to read close parenthesis. So once open and close parenthesis were there, then we need to pop out from the stack and need to put it into the postfix vector. So minus is going to be in the postfix vector. Next we are going to read the operand, which is D. We are going to put it into the postfix vector. Then minus. So already we are having one operator in the stack, which is star. Then we are going to insert minus into the stack, which is the lower precedence. So we need to remove the star from the stack to the postfix vector. Then only we are going to insert the minus. This is what happened over here. Next we are going to insert the open parenthesis. Then operand is read. We are going to insert into the postfix vector. Next plus operator, because it is the open parenthesis is there, so no need to check over the minus. So next one is f operand, going to insert into the postfix vector. Finally close parenthesis. Once we read the open and close parenthesis, we need to pop out and insert into the postfix vector. And finally whatever the things in the stack, we need to pop out from the stack vector to the postfix vector. Okay, this is how we converted the infix expression to the postfix expression. Next we are going to learn about the evaluation of postfix expression. As we know that postfix expression means the operand immediately precedes the operator. That is known as postfix expression. So infix means a plus b, prefix means plus ab, and postfix is ab plus. So here also we are going to evaluate it from left to right. This helps us in devising an algorithm. So imagine that the postfix expression is stored in an array, one operator or operand at an index. Okay, so let us look at the first operator starting from the left. Suppose that the operator appears at index k. Where are the operands for this operator? At indices k minus 1 and k minus 2. So it is easy to evaluate this operator, but where should we store the result? So storing it anywhere can be a problem. We may violate the property that the operands immediately precede the operator. So what should we do? Can we use a stack? How can it be used? What should we store in this stack? So we have to keep track of operands so that when we see an operator, we should be able to apply the operator immediately. Suppose we maintain the invariant that the operands are on the top of the stack. So once we evaluate an operator, where should we now store the result? The result could be the operand of a future operator, so pile it on the stack. The above suggests the following approach. For every operand, push it onto the stack. For every operator, evaluate the operator by taking the top two elements of the stack. Place the result on the top of the stack. So this is the pseudocode for it. Initially stack. With the help of looping process only, we are going to check it. If we found an operator, then pop the operand 1 and pop operand 2. And operator must be performed, manipulation must be performed for the operand 1 and operand 2, then push the value over the same process will be going on until the expression is over. So n is nothing but number of operators plus the number of operands. So let us see one example for it. For example, 875 minus 94 minus star 6 plus 4 slash plus. This is a postfix expression, as we know that operands after the operator. So initially the stack is empty. We are going to insert, whenever we found the operands, we need to insert into the stack. So obviously 8 is inserted into the stack. Then 7 we are reading. Again 7 is inserted into the stack. 5 then again onto the stack. So next thing is, we found minus. So once the operator was there, then we need to pop out, and we are going to pop 5 and 7 and subtract it, and result is put it onto the stack. Next we are going to push 9, then push 4, next push 4 and 9. Once we are going to get the operator, then we need to pop. I have written it wrongly here, so sorry for that. Pop 4 and 9 and subtract, and then push the result. And next going to pop the 5 and 2 and multiply and push the result. Push 6, then pop 6 and 10, add, push result. Now here next operand is 4, so we are going to push it onto the stack. Then pop 4 and 16, divide and push the result. And finally pop 4 and 8 and add, then push the result onto the stack. So the value of the expression on the stack top is 12. So whenever you are finding the operands, push onto the stack, and when you are reading the operator, then pop the topmost two values and perform the manipulation and push it onto the stack. This is how we are going to evaluate the postfix expression.